I think we can get started. Adam, do you want to, or are you happy for me to?
Yeah, take it away, I reckon.
Cool. Hello, everyone. Welcome to another episode of COMP6843. This week, we have a guest lecture by Srinivas. Um, I'm not sure if you guys got a chance to see his profile. I'm not sure if he has a slide on his profile, but let me tell you, Srinivas works as a offensive red team engineer for a large bank based out of Singapore. I've been lucky enough to know him for more than 10 years now. Is that correct, Srini? 10 years approximately. Um,
Yep.
Srini and I got a chance to work on some really cool projects. But other than that, Srini is an author of, I think, three books on information security. One of them is a basic ethical hacking 101 kind of book. The other one is on Android security. Like if you actually go to Google and search for what is a book on Android security, I think Srini's book will be one of the top books that's available for you. Also, he wrote a lot of articles on online, like and he also blogs on Android pen testing. He also spoke at like major conferences like DEF CON, B-Sides, etc. Srini and I were actually lucky enough to, well, I was lucky enough to be on site with Srini and give a workshop on Docker at B-Side Singapore last year. So I can keep going. I can keep praising him because one, he's my buddy, and two, he's a really cool speaker. But I don't want to waste time and probably hand it over to Srini so that he can teach us some really cool things about Docker. Over to you, Srini.
Yep. Thanks, Abjit, for the intro. Adam, how can I just hide this video?
Oh,
In,
if you've got a thing, we can't see it. If you've got a Zoom thing, we can't see it.
oh, is it?
Yeah. So it's all good.
Okay, so you can't see all the videos that I'm seeing here, right? Okay.
Just your.
So you're only. All right, that's fine then. Okay, so let's get started. So the session is on hacking and securing Docker containers. So the key focus is going to be on security of Docker containers. However, for those who are new to Docker or for those who are hearing about Docker for the first time, we will probably have a bit of introduction as well. So this is going to be the agenda for this session. We will have a very brief introduction and we will go through some Docker fundamentals. And then I'll show you some interesting Docker attacks on Docker containers. And finally, I'm going to show you some automated security assessments. And finally, we will leave some time for Q&A. But while I'm speaking, if something is not clear or if you have any questions, feel free to chat or leave a question in the chat, or feel free to stop me and ask your questions. Okay, so there are two sections. I have categorized this talk into two different sections. The first section talks about the fundamentals of Docker, and the second section is going to talk about attacks on Docker. So let's begin with the first one. And when we start learning anything, the first thing we want to learn is what it is. So what is Docker? If you just go to Google and type what is Docker, this is what you will see at the top of the results. It's basically a computer program that performs operating system level virtualization. So somebody, when Adam was asking what is Docker, somebody said it's something like virtual machine. Yes, it is. Just that in your typical virtual machines, you're virtualizing the hardware. You're making use of the resources that your hardware has. When you talk about containers, you're virtualizing the operating system itself. You're making use of the resources that your operating system has. So that's the fundamental difference between a virtual machine and a container. But as far as the definition is concerned, just remember that Docker is a software for containerization. Okay, so why do we need it? One of the important features of Docker is it manages all the dependencies. I mean, it doesn't manage. We will have to, when we build images, we can basically manage all the dependencies without having to worry about facing issues because of dependencies. For instance, you have developer one who is developing an application, And let's assume that it's a Ruby on Rails application. Typically, it requires a bunch of dependencies. Now, when you pass this application to developer 2, if he doesn't have all the dependencies that the application requires, he may not be able to run it properly. And that's when you can probably package everything into a Docker image, and you just pass it to developer 2, and all he needs is the Docker software on his machine. He can just simply spin up a container and he will be able to access the application. So that's one of the use cases of Docker. There are way more than this, but let's not get into all of them. Probably you can just simply Google about the uses of Docker. I want to focus more on security in this session. Okay, like I said earlier, this is the fundamental difference between a virtual machine and container. In virtual machine, if you see, we have hardware and we have a host operating system. In some cases, without having a host operating system, you can also have a hypervisor. And on top of this hypervisor, you will have multiple virtual machines. And if you notice, each virtual machine will have a full-blown operating system, which is the guest OS in this case. So on top of this operating system, you will have other software which is being installed. It could be libraries, applications, or whatever it is. Now, when it comes to containers, you won't have a specific operating system on the container. You will simply be using the host operating system. So that's the main difference. Obviously that brings down a lot of load and size, because in case of virtual machines, you will have a separate operating system in each virtual machine, which obviously increases the size of the virtual machine. But when you talk about containers, you won't have a special operating system. You're simply making use of the host operating system for all the containers. So it's pretty lightweight. And on each host operating system, you will have a Docker engine, Docker daemon running, and you will basically be interacting with that Docker daemon for a majority of things that you do with Docker. For instance, when you want to spin up a new container, you will have to interact with this Docker daemon. When you want to pull a Docker image from some registry, you will have to interact with Docker daemon. I'm going to show you another picture which gives you better understanding of that. But fundamentally, this is the difference between virtual machines and containers. Now, when you're learning Docker, especially if you're hearing about Docker for the first time, it may be confusing to hear the words image and container. So I just wanted to give you a bit of introduction to that. If you're already aware of Docker, I think it's fine. You might already know about it. So image is like your class and container is like an object. So from one class, you can create any number of objects. Similarly, within Docker, you can basically build one base image, one standard image. And from that image, you can spin up any number of containers that you want. So container image contains the complete packaging of your code. You will be creating an image when you want to run a web application or any software. You're basically building an image and you pass it to someone. When they make use of image to start a container, that's when they will run the code that is packaged into the image. So image is what you have, what you download, and container is an instance of an image. So when you start a container, you're basically making use of an image. So this is a pictorial representation of the same thing. Let's assume that you have an image called Apache Web Server, and from that image, you can basically spin up multiple containers. Similarly, if you have a MySQL image, you can just download that and you can spin up multiple containers from that image. Now, behind the scenes, when we talk about Docker pull, Docker run, Docker build, before that, let me probably show you a quick demo of this. I have a VM with all the commands already typed. I did not want to waste time on typing commands during this session, so I have just typed everything and I have kept them into a file. Now, let me just show you a quick demo of Docker images and containers. So I'm just pulling an image called Alpine. It's a pretty lightweight image. Majority of you might have seen it already. And when you do a Docker pull, if you see this, it has downloaded the image for us. Now you can use this particular image which is downloaded, and you can spin up any number of containers. So we have spun up one container now, and let me just start another one. And if you type Docker PS, you should be able to see both the containers that we have just started. And if you see, container 2 and container 1 are the names that we have given to these containers. So this is how we can quickly spin up containers on a machine. Obviously, we will have to install Docker client before that, and we need to have a Docker setup working fine. Now, as you have just seen, I have run Docker pull to pull an image from some registry on the internet, and Docker run to basically spin up a container from the image that we have just pulled. In both the cases, what happens is Docker client basically interacts with Docker daemon, and it will perform further actions that we have requested. For instance, Docker pull basically contacts Docker daemon first, and Docker daemon will first check if the image is already available on this host. If it is not available, it will go ahead and pull it from the registry that is configured. In this case, by default, it goes to Docker Hub, which is like an app store for Docker images. But in enterprise environments, we will also see private registries. We don't want to pull images from public registries, because anyone can upload an image onto the registry. It can be backdoored, or it could backdooring Docker images is also pretty easy. So anybody can backdoor an image and just pull it on the internet on Docker Hub, I mean. So it's pretty convenient to run these commands. And the next one is Docker run, we have just seen. So Docker run, once again, interacts with Docker daemon, and it will try to find out the image locally. If it is not available, it'll go ahead and pull it from registry, and then it'll spin up a container for us. So you run any Docker command, it will go ahead and interact with the Docker daemon that is running on your host. So that's how it works. Now, there are some interesting features that we need to know about when we talk about Docker. One of them is C groups, and the other one is namespaces. Once again, I'm going to just touch upon these concepts, but if you're interested to learn more about these concepts, I have included a URL here. You can just go ahead and learn more about these concepts. But let me just give you a brief intro to this. So Linux, both C groups and namespaces are some Linux features. They're one of the fundamental aspects of Docker. Now, C groups can enforce limits and constraints on your Docker containers. For instance, you're spinning up a container, and you did not enforce any limits on how much CPU that particular container can use from your host. Now, let's assume that that container is compromised by an attacker. Now, he can probably do a fork bomb or something similar to that, and he can probably consume all the resources from the host from within the container. So that's a problem that we want to avoid. So in such cases, we can basically use this concept of C groups, which can enforce limits and constraints on your containers. It can, as you can see on the slide, we can enforce limits on CPU, RAM, IOPS, and network. And namespaces basically provide the isolation between the host and containers. For instance, by default, if the root user creates a file on your host, and if a container is spun up by a non-root user, you can actually access this file, which is created by a root user on the host from within the container, even though it is spun up by a non-root user. So that means there is no isolation between the host's usernames. I mean, there is no isolation between the host and the container in terms of users. So we can basically make use of namespaces to avoid that. Some namespaces are by default enabled. For instance, PID namespace. When you spin up a container, you can't see the processes that are running on the host by default, but we can enable that by using namespaces. Similarly, when you spin up a container, by default, user ID namespace is not enabled. So the root user on the host and the root user on the container will have same privileges. So we're going to see some of the demos associated with C groups and namespaces. And once we are done with that, we will jump into some attacks. OK, so let me first show you a quick demo of C groups. So first, like we did earlier, I'm going to just pull up a container. Actually, we already have Alpine, so we don't need it anymore. Or rather, let me just spin up a new one. I'm just removing the existing containers. I'll just spin up a new one. This is the only command which takes more time throughout the session. Rest of the commands don't actually take a lot of time. Only stopping containers takes a bit of time. OK, so let's spin up a new container for this C groups demo. So I'm just spinning up a new container. And if you see, there is a hash associated with this particular container. And this is going to be used in creating the folder structure for this particular container. So what I mean is you will be using this particular hash in the path of this particular container on the host. So let's just find out that path. A specific directory will be created for each container on your host, which contains some details that we are going to see now. So if you see this, I have just used a simple find command, and I have specified this particular hash as the name. So basically, we are finding the entries associated with this container. And if you see this, we have a bunch of entries on this host associated with this container. And currently, what we are interested in is PIDs. So if you see this entry, let's probably navigate to this. And there is a file called PIDs max. So this file basically provides us with the details of what is the limit of the process IDs that can be created on this specific container. So if you see this, the default value is set to max. So what it also means is if this container is compromised, anybody can create a fork bomb, and he can basically create multiple PIDs, multiple processes on the container, and he can basically consume all the resources. Now, we can make use of C groups to prevent that. So let's spin up another container. So this time, I'm going to just make use of another. I'm just making use of this flag called --PIDs-limit, and I'm setting it to 6. So what it means is the maximum number of PIDs that you can have on this particular container is 6. So let's quickly find it out from here first. I'm just going back and I'm navigating to the directory associated with this new container. And let's do a quick cat on this PIDs.max. And as you can see, this time it has the number 6. So that means this container can only have 6 PIDs at any given point of time. Let's see if it is really enforced. So I'm just quickly going to get a shell on that particular container that we have just created with PID limit. And I'm just getting a shell on that. So to get a shell, I'm running docker exec, and I'm running it in interactive mode. I'm specifying the name of the container that I have just created, and I'm trying to execute /bin/sh. So we will get a shell on that particular container. OK, so if you see this, we are now inside the container. Now let's try to simulate creating some processes. So what I'll do is I will I first run docker stats on one of the tabs. So if you see this, I hope you can see the font. If you see this, the PID container is what we are interested in. And it has 2 PIDs already created on it. So let's try to create some more. I'm just going to run this sleep, or let's first run this. And let's see what happens. I'm just creating multiple processes. And if you see, the number of PIDs now is 6 on this container. And everything is done. Now it goes back to 2. Now let's try to create one more process. instead of six, let's make it 7. I'm just copying it and I'm trying to run it once again with additional sleep. And look at that. It says can't fork, resource temporarily unavailable. So that means we can enforce such limits using C groups and to ensure that attackers can't actually create things like fork bombs on a container. Now that's basically C groups, and the next one is namespaces. Like I said earlier, we can by default, if user namespaces are not enabled, the root user on the host is basically the root user on the container. I mean, there is no difference. Let me just quickly show you another demo for that. I'm quickly going to create a new file on my host. Before that, let me become a root. So I'm just, if you're wondering why the host name is master, it's part of my Kubernetes cluster. So I have named it master. Okay, so let's now create a new file in /tmp directory. So I'm just creating a simple text file. As you can see, we are just echoing some text into a file called important.txt inside /tmp. So this should create a file called important.txt. And if you look at the permissions of this file, it's owned by root, and the group is also root, and only the root user can read and write. Okay, so let's exit. And we are now a non-root user, but we are part of Docker. So if you are part of Docker, indirectly you are root, because Docker daemon requires root privileges on your host to operate. So let's see how we can make use of the privilege Docker to actually write some contents onto root owned files. So I'm just going to spin up a new Docker container now. Because I'm part of Docker group, I can spin up a new container even if I am not a root user. Just in case, if you want to know what's happening when I run this command, I'm using Docker client. Run is to specify that I'm spinning up a new container. -itd is some options we are specifying, interactive mode, daemon mode, and all that. And --name is to give a specific name to a container. If you don't give your own name, it is some random name will automatically be assigned. And now what we are interested in is this option, -v. We are trying to mount a volume from the host. In this case, it is /tmp, and we are mounting it onto the container into this directory. So when you spin up this container, if you go to this particular directory, you will be able to see whatever you have on the host inside /tmp directory. So let's hit enter. And let's try to get a shell on that container. I'm just going to use, looks like I didn't have the command. Let me just type it myself. Docker ps or docker exec -it, and let's give it the name of the container on which we want to get a shell, and /bin/sh. Okay, so we have gotten a shell. Now, what we are interested in is this directory, because that's where we have mounted the /tmp from the host. So let's go there. And if you type ls, you should see everything that is on /tmp on the host being mounted here. Now, if you type ID, by default, you're a root user on the container. If you don't specify any fancy options when you're spinning up a container, by default, you are a root on the container. So now let's just type ls, and let's type ls-l to see the permissions of this particular important.txt. Once again, it is having the same file permissions. Now let's try to write something. This is modified inside the container. And I'm just overwriting this. Now, if you go back to the host, and if you once again become root, and if you go to /tmp, and if you try to take a look at the file contents, you can see this is modified by the container. So to avoid this problem, we want to enforce user namespaces. So if you enable user namespaces, the context of the root user on the host and the root user on the container will be separated. So the root user on the container will be treated with a different UID and GID, and the root user on the host will be given a different UID and GID. By default, it's 0 and 0, but on the container, he will get a non-root user or something similar to that. So essentially, if you enable user namespaces, you won't be able to modify the root owned files of the host on the container. So that's the user namespaces. Now let's get into the next section. Before we move on, I have specified a link here. If you go to this link, you will find a lot of interesting lab exercises on Docker security. I think this is from Docker itself, so they're pretty useful. I have been following them for a long time, and I like them a lot. So I thought of just sharing them with you as well. Okay, so the next one is Docker security. Now, this is the attack surface when we talk about Docker security. When you have Docker containers running, when you have a Docker setup running in your host, these are some of the possible attack vectors. So external attackers, let's assume that you have deployed an application into a Docker container. Now, if this application is exposed over the internet or over the network, it's possible for someone to basically gain access to that container by abusing the application. Similarly, Docker also comes with something called Docker Remote API. It is, if you remember, we have been running some commands like Docker space pull, Docker space run, and all that. You can run the exact same commands over HTTP by using curl. That's possible using Docker Remote API. And when you enable this Docker Remote API, by default, it doesn't require any authentication. That means when you enable Docker Remote API over the network, anybody can spin up a new container on your host. So that's another possible attack that's under external attackers. Now, another one is malicious insider. Malicious insiders, we have just seen a simple example with user namespaces. A person who is part of Docker group can actually become a root user without, if he's a malicious insider who is intending to get root access on that particular host where he is part of Docker group, he can very simply get root access on the host. This particular use case is also applicable in DevOps systems. For instance, let's assume that you have a Jenkins system, which is supposed to start some Docker containers. Now, obviously, this Jenkins system should be part of Docker group. Otherwise, it won't be able to run Docker commands. Now, if this Jenkins instance is compromised, even though Jenkins is not running as a root user, since it is part of Docker group, it is possible for an attacker to gain root access by abusing this particular privilege of Jenkins being part of Docker group. So that's another case. And compromised containers. This is where we are going to focus more today. When a container is compromised, let's say you are an attacker, you have compromised a container. Now your goal is to get access on the host on which this container is running. So there are a bunch of attacks. There are a bunch of techniques and tools available to escape from the host, from the container to get a foothold on the host. We are going to see some of them today. So to summarize this slide, we have three major problems when it comes to Docker containers: external attackers and malicious insiders and compromised containers. Now let's begin with vulnerable images. Since we are downloading images from Docker Hub by default, it is highly likely that a lot of images are going to have a lot of vulnerabilities. If you scan any of those images with Docker security scanners, it is highly likely that you will find a lot of vulnerabilities. So I have taken one such image to demonstrate vulnerabilities in Docker images. So that's shell shock is what I have chosen. I'm not going to explain about what shell shock is. In case if you're interested in understanding more about shell shock, I think back in 2014 when shell shock was found, I have written a bunch of articles on these. I mean, these articles are available here on these URLs, so you can just probably go ahead and find them out yourself. Okay, so I'm just minimizing this, and let's switch back to the virtual machine. So what I'm trying to show you now is I will spin up a container by using a vulnerable image, and let's see how one can abuse that. Okay, so I'm going to use an intentionally vulnerable image called CV 2014-6271. This is shell shock, and I'm gonna start it here. Shell shock basically gives you remote code execution, especially when it is run using CGI. I mean, especially if it is CGI bin vulnerability, because shell shock is possible on HTTP, SMTP, SSH, and all that. If a vulnerable instance is found over HTTP, it is highly likely that you will get a remote code execution on that. So what I'm going to do is I'm just going to abuse this shell shock vulnerability that we have here. So here, what we have done was we have just started a container here, and we are exposing port 8080 on the host, and port 80 is actually being used to run this vulnerable application on the container. So -p can be used for port mapping. You're basically, it is something like port forwarding. You can, so port 80 of the container is being used to actually serve the application, but you are using port 8080 of your host to actually map onto that particular port, which is exposed on the container. So essentially, if you can just try localhost colon 8080, you will be able to access this application, which is running inside the container. Now, I'm just going to run this command. It is a standard command to exploit shell shock. So that's why I'm not going to get into more details about it. But if you see this, we are presenting a custom user agent with some remote code execution payload. So let me just type it again. I think the container is stopped. Let me just spin it up once again, and let's run it. Just restart it. If at all this demo fails, please don't blame me. It always worked. If at all it fails, this is the first time it is going to fail. All right, so I'm just spinning it up once again. I'm starting my shell shock container, and I'm trying to, I think it's not going to work. Probably at the end of the session, I will tell you how you can view this demo. Abhijit is giving a smile. All right.
I have seen this work before, if you remember. So I'm just like, Srini, because I've already interrupted, I just want to ask you, do you want to take all the questions at the end, or do you want to maybe answer a few of them now, or?
We can answer some of them now. I think we have enough time.
Sure. Anyone who wants to go ahead and ask the questions, or I'm just going to read them from the chat window.
Can I ask a question about the Docker file system?
I'm sorry?
Can I ask you a question about the Docker file system?
Yeah.
So Docker uses AUFS, but how is that actually mapped onto the host?
I'm not really sure about it.
Like, I think so when you go into a Docker container, are you chrooting yourself to get into its file system, or is it running in an isolated environment?
I'm not sure how it is internally mapped here. Probably I'll get back to you on this.
Okay.
Yeah. But
Hi,
that's
Srini.
a good question. Yep.
Hi, hello. Just wondering about your demo. When you are trying to spin up the container, it says that the IP was not set, was it? And then it uses some other IP addresses as default. So could that be the reason? Instead of localhost?
This is just an error. It's a standard message from the Apache server. I don't think that's a problem. But
that's just saying that Apache can't find a fully qualified host name.
Yeah, but that's standard. That's a standard message from Apache. But let's just try with a different IP address. This one we can try. I think the image has some problem, I guess. I'm not sure if they have updated something. Nope, it doesn't work here. At least this IP should work.
If you're connecting to that IP, is it still port 8080?
Yep, it should still be, because we don't know the container IP address here, right? So we are just mapping the port from 8080 to 80, and then we are trying to connect from the local host. If you see this, it's the host's port, so we are just trying to connect to the host's IP address and this port. So I doubt that the web server itself is not running. We can try accessing it here. Yeah, I think there seems to be some issue with the image, but that's fine. I have this demo recorded and I'll give you a link to it at the end of the session.
Thank you.
Yep. I'll move on. So the next one is checking if we are inside a container. Now, when we get a shell on a container, it's very important for us to know that we are inside a container, because we are getting a shell remotely as an attacker. So we should be able to differentiate between the shell on the host as well as on the container. So let's just do a quick Docker PS. I think we have killed all of them. Docker run -itd. Fine. So I'm just going to get a shell on this quickly. So in the latest versions of Linux, we will have a C group entry for all the processes. So what I'm going to do is I'm just going to read the C group entry from the proc file system here, proc self C group on the container. And if you see, there are a bunch of entries with the name Docker. Similarly, if you run this command on a Kubernetes environment, you should see something like pods. So if you see pods here, that confirms that this container is running inside a Kubernetes cluster. If you just see Docker, it is highly likely that it's a standalone container. Now, if you run it outside the container, you will see a different set of output. As you can see, there are no Docker specific entries here. So that's one way to determine that you're inside a Docker container when we get a shell remotely. Right, so the next one is some standard container breakout techniques. It said you are not connected to the internet. I think I didn't get the question. I'll probably take it at the end of the session. Somebody was asking.
This is about when we were doing the demo on your VM,
Okay.
it showed us a small prompt which says like you're not connected to the internet.
No, we are connected to the internet because we are able to pull images from Docker Hub.
No, I think that's when he was trying to connect to port 8080.
Yeah.
So it's saying that the container is refusing the connection.
Okay. So anyway, we will try to, if we have enough time, we will probably try to do the demo at the end of the session. Let's not get into that again. I mean, I always prefer not to do troubleshooting during a session. Okay, so let's get into some container breakout techniques. So there are a bunch of techniques that can be used for container breakout. One of the most commonly used is abusing the capabilities the containers may have. If the container is started using privileged flag, it is highly likely that you can escape from the container and get access to the underlying host. Sometimes containers may be started by mapping this particular docker.sock onto the container. So that particular feature is required, especially when the container needs to monitor other containers, or the container needs to view some logs from other containers and all that. One example of that is Portainer. So Portainer, if you have ever used Portainer, this is a container that I think monitors other containers on the host. So if you have mounted this /var/run/docker.sock onto the container, you can basically spin up a new container from within the container. So that's going to allow us to escalate the privileges by getting foothold onto the host. Another one is abusing the capabilities that container has. For instance, if you look at this, I'm talking about capsys module. Similarly, we have capsys admin. Similarly, there are a bunch of other capabilities that can be used to execute something on the host directly from the container. So I'm going to show you these two demos now. First, we will start a container by mounting up this /var/run/docker/sock onto the container, and we will see how we can escape from the container and get access to the host. And we're also going to run a simple kernel module to abuse this capsys module capability as well. I'll talk more about capabilities in a moment, but let's begin by showing the docker.sock issue. So docker.sock. Okay, so I'm going to spin up a new container here. So docker.sock is basically the Unix socket that you're interacting with. Whenever you type Docker commands, you're basically interacting with the Unix socket. Like I mentioned earlier, we can have a Docker remote API. Otherwise, we can also have Docker sock from the command line. So if you're having Docker remote API, you're invoking this Docker. We are invoking this Docker. I mean, sorry, we are interacting with the Docker daemon over HTTP. But by default, we are trying to interact with this Unix socket, which is available here, var run docker sock. So I'm just quickly spinning up a new container by mounting this Docker socket onto the container. So let's hit enter. And now let's assume that somebody has gotten access to this container. Docker exec-it, and let's specify the name of the container. In this case, it is sock, and /bin/sh. So we have gotten access to this. So as part of enumeration, I think this is one of the things that we can look for. We can check if this particular Docker socket is mounted here. So we can do that here. So as you can see, docker.sock is mounted here. So if it is mounted, it's highly likely that we can escape from this container and get access to the host. So to do that, we need to have Docker client available on this container. But in this case, it is not available. So since we are using a Alpine image, we can use apk add -u, and we can install. Let me just copy it from here. Not sure if it requires an APK update, but let's do that. Okay, so once that is done, we can simply install the Docker client onto this container. And once that Docker container is installed, we can basically spin up a new container by mounting the host's root directory onto the container. So this is what we have already seen earlier, but let me just show you with the root directory. Earlier, we have mounted /tmp directory from the host, right? So we are basically doing the same thing, but from the container itself. So we are using the Docker client that we have just installed, and we are mounting this volume onto this new container that we are spinning up, right? Let's hit enter. And we are automatically getting a shell on this. So basically, after spinning up the container, we are getting a shell on the new container itself. So if you now type ls, you should see something called test, as you can see here. Let's navigate to that. And inside this, whatever you're seeing is from the host. So for instance, if you see /etc/shadow, this file is actually from the host. So let's take a look at the contents. If you see this, the username is master here, and this is the password from the host. So basically, we are able to read the shadow file from the host. So that means we have basically escaped from the container, and we have gained initial foothold on the host itself. Okay, so I think somebody was asking something. Okay, all right, so another one. I'm just going to show you another demo, and I love this because I never thought something like this would be possible. So when you spin up a container, and if it has a specific capability called COMP6843 module, you can basically install a kernel module onto the host's kernel. So let's see how we can do that. I'm just going to first spin up a new container with some additional privileges, basically to have that particular capability that I'm talking about, which is COMP6843 module. To do that, I'm just going to spin up a new container like this. If you see this, there is one additional option here. We are giving it -- privileged. So I'm just hitting enter with this, and let's get a shell. And I'm just going to show you what happened when we gave -- privilege to this container. -it, and let's give it a name. Let's give it the name of the container, which is kernel in this case, and /bin/sh. Okay, so we have gotten a shell on this new container called kernel, and we have given it -- privileged option. So what happens is when you give -- privileged, the container will be started in privileged mode. What does it mean? What it means is by default, when you start a container without this -- privileged option, even though you're getting root access on the container, I have shown you that earlier, even though you're getting root access on the container, you're actually not going to have all the privileges that a full root user can have. What does it mean? So you can actually segregate all the privileges that a root user can have into distinct units. And these distinct units are called capabilities. When you start a container using -- privileged, you will get all the capabilities that a root user can have in the container. If you don't use that -- privileged, some of the dangerous capabilities will be automatically removed from the container. So in this case, we are explicitly giving this particular container with -- privileged option. So we are going to have some more dangerous privileges on this container. So let me just show you how we can verify the privileges we have. So we can list out the capabilities we have by using capsh -- print command, but capsh is not installed by default. So we will have to install it in Alpine. I think in Ubuntu systems, it's by default installed. So now I'm just typing capsh space -- print. And if you see this, these are all the capabilities that we have now. And what we are interested in is COMP6843 module. This is COMP6843 admin. This is another one. If you have this COMP6843 admin, and if you can see the PIDs from the host, it is possible to inject something. It is possible to do some memory process injection. and get access onto the host. But in this case, what we are looking for is CAPSys module. You should be able to see that somewhere. In case if I can't show you here, trust me, you should be able to, yeah, it's here, CAPSys module. Okay, so all we need now to escape from the host, to escape from the container onto the host is this particular capability. So even if the container is not started with -- privileged, but if the container has this particular capability specifically, we can still escape from the host and gain escape from the container and gain access to the host. So let's see how we can do that. I have created a very simple kernel module. Let me just show you the contents of it. This kernel module basically gives us a reverse shell on the local host. Oops, that's a compiled binary. Okay, so here, if you look at this, we are basically doing a reverse connection from within the kernel to this particular 172.17.01.4444. So essentially, we will have to have a listener on port 4444. And all we have to do is we will have to just compile this kernel module and install it on the container. Now, when you do that, it is going to be installed onto the host's kernel, and it is going to load automatically, and it is going to give us a reverse shell. So in my case, I have already compiled it just to avoid any problems. I have kept it compiled. So this is the kernel module I have that I'm going to pull onto my container. So I'm just spinning up a new simple HTTP server here, and let's just pull it down. wget 172.17.0.1 and 800/kernel_module-ko. Okay, so we do have this here. Let's give it executable permissions. And we do have this listener running here. Now let's quickly install this kernel module from within the container, and let's hit enter. Sorry, there is a typo there. Not sure what went wrong here. We do have CAPSys module, and we do have executable privileges here, and it should work. Invalid module format. Let me just try to compile this once again, and let's see. Okay, there is a new file here. Let me just transfer that. Not sure what went wrong. Let me just show you how that works real quick. I think we will have to skip this demo as well. I'm sorry about it, but I'm gonna show you, I'm gonna give you one resource where you can see this demo once again. I can't quickly determine why it is not working because I have tested it last night before this session. I think we are getting some suggestions. Yep, files are
Srini, the
injected.
students are saying demo cards need some sacrifice.
Yep, looks like it. I made sure that all these are working last night, but I'm not sure. -ko files are injected with INS-Smart. INS-Smart, yes, that's what I was trying to do here. Was I doing something wrong?
Not as far as I could see.
Sorry?
I couldn't see you doing anything wrong. I think just the way the module was compiled is it's
Yep.
complaining.
Yes.
You might need to use // for like after the ins mod.
Actually, not required.
Like // kernel module.
I don't think so. It's not needed.
Okay.
Actually, that's why I kept everything available here, just to make sure that I'm not making any mistakes.
Sorry,
but
we're at the
I'm not
point in the
sure.
demo where you try everything.
I'm sorry?
We're at the point in the demo where you try everything.
Sorry, I didn't get that.
Don't worry.
Okay, so yeah, I'm gonna just give you another resource where I have demonstrated this over a video. So probably you can just take a look at that after the session. If you guys have any questions, we can take a look. Otherwise, I have one last demo. If you don't have any questions, I will go with that.
Can I ask you a quick question about the Docker socket vulnerability?
Yeah.
Is that safe if your container does not have outside access? Like in this case, getting into the container was trivial because you just opened up a shell interactively. But how vulnerable are containers to being accessed from outside if they don't have open ports?
If the container itself is accessible from outside, let's say you're just getting a shell on the container, but it doesn't have any dangerous privileges, then I think it should be okay. But if it has any dangerous privileges like socket mounted or any capabilities that are dangerous, then probably, yeah, that's a problem.
So if you're going to use a container to manage your containers using Docker socket, that should not be accessible from the outside.
Yes,
ever.
because you're mounting this docker.sock inside, and obviously that's a problem because you're essentially giving access to the underlying host. Yep. Any other questions? Okay, so if not, we still have 1 minute, so I'll just probably make use of that to run another tool called Docker Bench Security. So it is not going to take a lot of time. I'll probably just run this real quick. So this Docker Bench Security is a tool which can be used in enterprise environments. It is probably not useful for students, but it's really useful for enterprise environments for assessing the security of the Docker setup within the organization. So it makes use of CIS benchmarks to assess, to ensure that all, I mean, it's not to ensure, but it is going to give us, it is going to perform a lot of different checks, and it is going to tell us what can be improved in the setup. For instance, we have just started a container using -- privileged. And if you look at this, there is a warning: privileges not restricted for this particular container called kernel. Similarly, privileges not restricted for this container called socket, because Unix socket is mounted onto the container. And Yeah, so similarly, there will be some other, I think this kernel container as well as this, the container kernel and the container sock have a lot of different problems, it seems. So it is reporting all of them. And it does checks against, checks in multiple areas. For instance, one is container runtime. So whatever the issues that we have just seen are associated with container runtime. Similarly, it can find issues in Docker images and the build files. Similarly, it can find issues in the Docker daemon configuration. For instance, if you are exposing your Docker daemon over HTTP without any authentication, that will be flagged here. So it is it's very good tool, especially if you're in an enterprise environment, right? Now, I know I was expecting that some of the demos failed, even though I have verified that everything working. So I have come up with one additional slide for all of you, expecting that these demos would fail. So if you want to learn more at your own pace, and if you want to see all these demos working, you can take a look at this course, which is available on Udemy. I am the author of this course. And at the same time, I don't want you guys to go and buy it just because my demos failed here. So I have come up with a free coupon code. It's free for anybody. If you have 1,000 students, probably you can share with all of them. And you can see all these demos working there. And it is valid only for 2 days. So if you try to access this probably after a day, it'll ask you for money. So try to be faster. Okay, so just use this coupon. Let's escape. And all of these concepts that I have discussed, and along with that, some more concepts are covered there. And I'm 100% sure demos won't fail there.
But thanks a lot, Srini. One of the students is like, looks like you don't trust the demo gods, and they got angry, and that's why they didn't work during the lecture. But no, I mean, trust me, when we do this.
It's really unfortunate because these demos that I have just failed have never failed. This is the first time. I did this session just 2 weeks back, and especially the kernel module, I can't think why. Because last night it was having some issues. I fixed all of them and I verified that it is working. And I created a new virtual machine. I verified this morning just before the session, and exactly during the session it failed.
Does the coupon code expire in 2 days?
Yes. So you should register within 2 days so that you will get this course for free. If you try to access this link after 2 days, the course will still be available, just that you will have to pay something. Like $10.
If you register within the 2 days, is it available permanently or only for the 2 days?
It's lifetime. It's lifetime access.
Very generous, very cool as well.
Wait. It says the coupon code is not valid, but can you please?
Oh yeah, yes. I have actually disabled it last night just to avoid unintended use of it. Probably after 5 minutes after this session, I will quickly enable it. Try it again. If it doesn't work, please contact me. I mean, you don't have to contact me. It will work. My email ID is here, and you have Adam, you have Abhijit, and it should work. If it doesn't work, I won't give it to you. And one more thing, that course covers everything that you need and everything that I wanted to show in this presentation, but except for this kernel module. So you may probably want to take a screenshot of this kernel module because I haven't given it out.
This meeting is being recorded, so.
All right, that's fine then. So anyway, I'll just quickly show this. This is the C file and this is the make file. Yep, so all you need is these two. If you have this kernel module, just try to run make command and it should produce the .ko file, and just try insmod, it should install the kernel module in that. Yep.
Cool. You guys have any more questions?
Let me just stop the share and enable the coupon right away so that they will not have any questions about it. You can't see my screen, right, Abhijit?
No, I can see your beautiful face, Srini.
Not the screen, right?
Do you guys need a breakout room?
Yeah.
Good one.
No, we can't see your screen.
Yeah, that's fine. So can you try now? The coupon should be available now. I have enabled it.
Yep, I just tried it and it seems to be working. Yep. Thanks, Srini. That was very generous of you. I really appreciate it. I'm sure for those who have kind of attended but have more questions about it, they might go to the video lecture and then get their answers to the questions. If not, in the chat, I'm just posting Srini's Twitter ID, so feel free to reach out to him if you guys have any other questions. Otherwise, thanks a lot, Srini. Appreciate it.